Okay, so I'm back for another live stream, and in this stream, I have these two circuit boards that I will be doing assembly for and testing. I do know of two things that have to be fixed on them, so there will be another revision on these boards. But let's do some surface mount soldering. So these circuit boards are combined with a 3D printed piece that holds them in place. And with this board, with the circuit board and the panel, you can have push buttons that can be connected to a home automation system. They also have the D1 minis or ESP8266 that it will connect to on the back. And because there's a screw hole, I will actually be using headers to plug it in. I think the next revision will actually just use the ESP on its own instead of plugging in, but I will play around with that layout at a different date. I have the stencils for the solder paste, and I think I have all my tools ready to go. I don't think I'm missing anything. Actually, I know of one tool I'm missing. I'll be right back. Almost forgot the screws to mount everything. So with the 3D print, this one has lettering and a logo filled in with paint. Now you could potentially do it with a layer change in the 3D printing software instead, or multicolored 3D printing. This is filled with paint and then polished, wet sanding all the way up to 2000 grit. The ones that I'll be using with the actual buttons, these are only sanded to 120 grit, so they're still a little rough. You can paint them, you can leave them 3D printed, or you can obviously polish them. And then this one has the acrylic inserts for the ring lights, and then the buttons fit in the back. They are sanded to fit nicer, but I might play with the 3D printing tolerance. The problem with these ones is the acrylic tends to vary in its width, so you kind of do have to sand them to make them fit nicer. But they're designed so that they won't rotate in place or anything. They just stay where you want them to, and the buttons on the back should hold it in place. Now the other version is this one, where the light is actually in the center of the button. You probably can't see it very well. It does blend in very well, but the light is in the center. And the circuit board for that one actually has two buttons so that you get better stability in the button and better chance of actually pushing and activating it. So solder paste, 3D printing holder, and we can start with the stencils. Let's start with the one board. So we can put our board into place. And which way does the stencil go? This way. So this way? It's this way. Yeah. We can put our stencil into place. hold it. Make sure it's in place properly. Yep, there we go. Solder paste and a little scraper. Let's see how that turned out. Yeah, it looks good. Don't think I'm missing any pads. Nope, not missing any pads on that one. Move it a little closer to the camera. But not missing any pads, so hopefully that one turns out. I'll clean that off later. And then we got a second board. Now the reason I'm doing two of these is I actually have both warm white and cold white LEDs. So I'll be doing one in both, but I only have enough parts to do 3 boards. I didn't buy enough switches to do more. Although these boards really aren't ready for production anyways, because I do have to make a change to them. And the change that I have to do to these is the NeoPixel pin and button 4. D0 isn't strong enough to run the NeoPixel data line, and digital pin 8 is a pull down, which means the button doesn't work correctly. You really want to squeegee the whole thing at once, but this does work fairly well. Did get some smearing over here, so let's clean it off. And everywhere else on the board is okay. Let's fix this too. Just to make sure, get a little piece of paper towel. Okay, and let's try that again. that's better. And nope, that port's in the wrong spot. Rotate that around. Yep, that should work too. Okay. Now that we got our boards, let's place some parts. So I only need 3 of these 10 UF capacitors. One there. One there. And one there. That's those. Need a bunch of these 0.1 capacitors or 100 NF capacitors, nanofarad. Each port is 1, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is my volume really low? Or is my microphone a little too far away? I'll raise up my volume a little bit. Hopefully that helps. And I've moved my microphone next to me. I already lost a capacitor in this. Ooh, no. These things are so small. These are 0604 or 03. These are the smallest parts that I tend to deal with. So let's start placing them. Let's see how many I'm missing. I got stuck on my tweezers. Let's try that again. 1, 2. Thanks, Frank. It's funny, I don't adjust the volume much between the streams, so I find it odd that it's always low at the beginning. Although it might have just been the microphone placement this time. Should get a boom arm for it. And that one's that. One there. One over there. There. One more. There we go. Should get a microscope for doing these. That'd be kind of handy. 4, 5. Oh, I already did that board. One there. Fix the solder paste on that one. Okay, that's another part done. And that's the buttons. That's the power supply. Oh, dropping something back here. Capacitor. Only need 3 of the 470 ohm resistors. That's 1. It's upside down. There we go. One there, and the last one. And this is the resistor for the NeoPixel data line. Just fixing the solder paste on this. Okay, that's that one. This is the 3.3 volt regulator. Now these boards are labeled up to 30 volts, but this regulator is actually only up to 18. Although I do intend to swap it out for a different one later. And this is a 3.3 volt regulator for the Wemos. It is also powering the LEDs, so there is no level shifting on them. And these are the push buttons. The ring light version uses one button. The center LED version uses two buttons to give stability to the button and to prevent chances of the button not actually being pushed when you're pushing down on it. They're simply wired together. That is the buttons. Let's do the LEDs next. That's the warm white. It's cold white. Let's do the warm whites first. I need 16 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Hello, James. Yeah, it is dinner time. I had an early dinner because I knew I would be streaming, but I tried to pick this time so that anyone in Australia could also watch. Let's see here. the good news is I got the code working already, and I have it flashed on the ESPs or D1 minis. I couldn't get Tasmodo to work properly with the lights, but I know there's a config file. I just haven't been able to find it. So maybe I'll play with that later, but I do prefer running custom code anyways. But I know not everyone would. Right. I need to figure out which orientation these are going. So, go to board view on Eagle. That's the wrong board. Switch to the other board. There we go. Okay. So if we start from here, need to adjust this footprint. Every time I get a board made with these LEDs, I always forget to change the footprint so that I know what orientation these go in. Should all be the same. Yep, there, okay. So these ones are warm white. I wanted to demo what they could look like. There's one other option, which is neutral white. And then you also have the warm white, cold white, and amber built into one, but you don't get RGB with that version. And then, of course, you could just buy RGB and not have the white at all. But I do prefer having a dedicated white. It uses less power, and it looks nicer if you actually want white. Okay, there's one with the warm white LEDs on it. There's only missing the big capacitor on it, and a few other parts. Cold white. I need 20 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And I know that board's the same, but the other board, let's open it up. Nope. Yes. There was solder paste on it. I have the stencils for the boards, and then I have a 3D printed piece that holds everything into place so that I can line it up nicer. That is very handy for doing multiple boards at once. I had a project where I did 50 boards with these LEDs on them. Managed to do about 50 boards in 3 or 4 hours, which wasn't too bad. Turn all the LEDs over. Now, for this version, there we go. Okay, and last surface mount component is these are large capacitors, and this is the power filtering for the NeoPixels. Although I'm only using one regulator, so it is also filtering power for the D1 Mini. And into the soldering oven they go. Let's turn it on. It's got a fan, so it's gonna make some noise. And let's start that. There we go. And that will take about 7 minutes. Should turn on the soldering iron. Going to need 3 of these Ethernet connectors. And maybe diodes. There's 4 for each one. That's 12. 5, 6, 7, 8, 9, 10, 12. And then we've got header pins for the D1 minis, and we need wire. So we have 2 spots that are gonna need wires put in place because I noticed an error. So the NeoPixel pin originally in the schematic uses a D0. I found when writing the code, D0 is not strong enough to run the NeoPixels, so that does not work. The other issue is button 4 is currently connected on the PCB to digital pin 8. Digital pin 8 is pulled low for booting and has a pull down resistor. Thus, it does not work when you try to set it as a pull up for an input. And thus doesn't work in this current design, so that will have to change its pin as well. And I think there's one other thing that has to change. I didn't add pull-ups for the connection to the Ethernet jack, so the design will only work if it's actually connected to a light switch controller that has pull-ups enabled. So I plan... Oh, no worries, John. There'll be playback after the fact. So I forgot the pull-ups on the Ethernet connection, so it only works if you have it plugged into a light switch controller. And I do have an external power connector on the board for if you wanted to just run power and use it on Wi-Fi only. So I have to fix that in the next revision. So that you could run it without a light switch controller. The bonus of running it with a light switch controller is that you could have failover control and know if either the Wi-Fi isn't working or if the light switch controller wasn't working, then you could use just the Wi-Fi. And we're about halfway done on the soldering oven. So just kind of a waiting game now. Yes, so what I actually have set up so far is when they first turn on, the lights are partially red. It's more evident on the ring light version. I do get some fumes from the oven. I don't mind it too much. Um, and then, but for the lights on the buttons, um, you have two versions. You have one with just the center of the button is lit up. So in this case, when it's first trying to connect to Wi-Fi, they'll all be red. Once it's trying to get an MQTT connection, it will go white. Most of the time you won't see that, at least in my testing. It connects too fast, so you rarely see it go white. But once they are connected, it goes green for a moment, pauses, and then goes into the normal programming. On the version with the ring lights, instead of it being completely red, let's put this button back into place. It actually only lights up one of the four red, and then it does the same thing for the white, and then it goes completely green, so that you know it's both connected to Wi-Fi and MQTT and is ready to go. I did want to animate those colors, but it wasn't working right, so I might go back through the code and change that. Now I have these created, and they're just rough sanded 3D print ABS, 120 grit. You could paint it to match your trim in your house or whatever you wanted. But you can also do this where you can 3D print labels or an image into a 3D print. This is done with paint. You could also obviously do it with a multi-material 3D printer, or set up multiple 3D prints and switch out the color manually. And then it's done with wet sanding and plastic polish to make the panel look really nice and shiny. And the circuit boards just bolt to the back with captive nuts. Yeah, it definitely makes things easier to know when it's properly connected. The other thing I have set up in the code, let me open the code. And I can, while we're waiting for the soldering oven, I can show some stuff in the code. So in the code, most of the stuff that you're going to have to change is right at the top. So first you have host, which is the name you can give the device. This has to be unique for each one. And this will both be the name that the device will appear as on your Wi-Fi network. So if you go looking for it, it's easier to find. Its IP address and whatnot. Then you have your Wi-Fi password information. I do use a user and password on my MQTT broker, but obviously probably don't need it. And then the output topics that it's using, it's actually doing it all automatically. So we have 4 different topics that are being used. It uses the host name and then adds the /button, /heartbeat, /RGBW, and fade. RGBW and fade are inputs for controlling the lights, and I'll demonstrate what both of them do. Heartbeat, every 15 seconds it will send out a 1. so that you could, in Node-RED or Home Assistant like I use, you would be able to know if the device is online or if it has fallen offline. And then button is the output. It outputs the number of the button that has been pushed, starting from 0 to 3 for this 4 button example. But it automatically uses the host name to add into the topic. And then everything else is just controlling lights and stuff and the connection. And this is going to end up beeping in a minute, and it's going to make a heck of a racket, so headphone warning. Switch back to overhead view. There we go. Looks okay. Nothing's melted. Was a little worried with those aluminum capacitors if the normal setting that I use would be too hot for it. Now if I can pull one out without burning myself. And where is the magnifying glass? Here it is. Yeah, button survived. Thing looks okay. So, actually, yeah, they're not too bad. It's cooling off quite nicely. So I do have connections here for a terminal block, but you can change the solder jumper to either use the terminal block or to use the Ethernet connector for power input. So what I do need to do is I need to cut a track, well, 2 tracks. One is this one here. Should really find my X-Acto knife. Let's see. I'm sure I have an X-Acto knife around here. Yeah. Nope, that's not working very well. I thought I had that X-Acto knife out. Ah, there it is. I think I broke the connection. Yep. And the other one that needs to be changed is down here. Okay, that should be separated. Turn off the soldering oven so I don't have to listen to the fan. And add some solder for these 4 diodes. Oh, there's no marking on the circuit board. Put up the board design. It should be schematic view. Should be going towards the button. Other way around. Let's get the sticky tack. There. That'll help. Ooh. Did I just lose that diode? I think I did. Solder the other side of the diode. That should work for that. Still need the wires. Now I know I'm gonna add wire to this track. So one wire goes to D3 and D2. pin header. But I accidentally filled one of these holes, so this should be fun. There we go. Side of the pin header. One. Stop it from flopping around. A little bit of this blue tack doesn't want to be sticky. Let's try this again. I didn't think these wires through. Because the 3D print sits right flush against it. I'm gonna have to sneak it underneath. Wait, no, wrong wire. Try and leave this connector a little proud of the board so that I can sneak those wires in underneath it. Now, let's try and connect these wires. Actually, I just realized. I can just put them on top of this. Nope, wrong version. leave it off to the side. Check my notes. New pixels, gone D3. Button goes to digital 2. Now the other thing I am worried with the design is getting a cable around that Ethernet connector. Yeah, well, that cable most certainly does not fit. I knew that was going to be an issue. I do have other connectors and cables that I can use. But let's finish assembling. And I can grab those tools. Oh, there's one board. Yeah, it's got everything. Next one. Need. Hope I cut the right one. Yeah, I did. Yep, okay, and the LED wire. I don't think the LED wire goes on the other side, which is a problem. Let me check the board view. It does not. Well. Pin for that is D0. Move the pin for that, and I can solder around it. There. Make sure that's straight, and it is. Let's do the diodes. No, I need an extra diode. Where did I put the bag for them? There we go. If I could put all these posts on one side of the board, it would be lovely. A lot less soldering. Let's see if I can't there. Now it won't move on me. Tweezers. Apply some solder. Last connector. And get wires for that as well. So, one wire. Tin these wires. Oh. this way because there's a view right next to it. Nope. There we go. And then one wire there. One there. That, nope, I need the Ethernet connection. Okay, that's that one, and last one. Let's cut the trace. See. It's always hard to tell if it's actually broken. Yeah, it's broken. Although granted, I could just get the multimeter out. But one. Oh, that, well, that capacitor didn't solder very well. I don't think it got hot enough in the oven long enough. Rest of these look okay. Might just been the position it was in the bed. Normally I try to center boards, so I guess I can't really fit 3 of these in at the time. Or I just have to put them closer together in the oven. Right. Yep. Now, last set of pin headers and pulling out third pin. Other pin header. And need some wire. Oh, I put those pin headers upside down. No. Am I going to be able to get it off? Or am I going to have to cut it off? I'm going to have to cut it off. Thankfully I got spares. Spares. They are the longer pins, so I'll just have to cut them, but... Okay. Let's see if we can't remove these. Moving around too much on me. Brand new sticky tack ain't sticky. Last one. There we go. Let's try that again, but let's do it the right way around. Let's cut these pins short. Okay, let's see. The side. Let's add some solder. Well, I just got sticky tack down the holes too. It's definitely not elegant, but this design has to change anyway, so let's see if I can still salvage this. I'll test it with a multimeter once I can get the D1 Mini on it. This is so annoying. Let's see if I can just add solder to this. At this point, this one doesn't have to look pretty. I just want it to work. Okay, let's cut the wires for it. Using automatic wire strippers, hence the noise. Now, and the last one. Okay. Doesn't look pretty, but let's see if those connections actually work. Multimeter. Ohmed out. Yep. Well, they all appear to have connection. So, all I need is an Ethernet cable that works. So, to test it, I have this Arduino Mega, which is acting as the pull-up for a light switch controller, because my infinite wisdom, did not put any pull-ups on this design, so it will not work without being plugged into a light switch controller. So I will fix that later, so that if you're putting it somewhere after the fact and you don't have Ethernet but you have power, you can still make the thing work. Yeah. So this should fit like so. And should have screws here somewhere. I already put the captive nuts in after I finished the 3D prints. These are M3s. This one doesn't want to go in properly. Why not? Let's try pushing that nut back into place. I think it shifted. Well, it just does not want to go. I think that one's working. Sound key isn't getting it tight enough. Too much slop. This is annoying. Should have tested this ahead of time. Don't think the captive nuts are aligned. Try that again. Either that or these screws are too long, which they shouldn't be. Yeah, I'm starting to wonder if the screws are too long. There's holes underneath the captive nuts, so it shouldn't be bottoming out. Looks like this one screw is now stripped. Let's see. Let's see if I can pull it out with pliers. Let me check my stash and see if I have smaller ones. I do have smaller ones, but I think they will be too small. So let's try offsetting. Try to find which one is damaged. I think it's that one. Well, let's try offsetting with an extra nut. Yeah, the captive nuts aren't completely aligned, and it might be just an issue of 3D printing tolerance. It caused them not to align correctly. Well, let's hope that adding a nut to that will space it out just enough to let it to fit. Goes this way around. It's not even grabbing the screw anymore. Might be too short now. Nope. It's not long enough now. So, let's see if I can't get this to go in correctly. That went in correctly. Let's see if I can get the other one to do it. Hopefully that's in position. Now just hope the buttons have the right tension. think this fourth one needs adjusting. That's the 3D print tolerance, I think, is making that one too tight. Yeah. Thankfully, I got some sandpaper handy. Did my overhead camera drop out? I think it did. Nope, it's working. Look, it's not showing anything. Let's stop it. Start it up again. There we go. Oh, what did I drop it to? Well, definitely not going as smoothly as I thought it would. Who I was thinking I could put these together in about an hour. Okay. Think that should be resistant free enough that the button can work, although Just make sure they'll click nicely, and they do. So yeah, I think we can hear it. They all click nicely. So I definitely have to adjust 3D print tolerances for that part, the buttons. So you don't have to spend forever trying to sand them. Yeah, that's still sticking. It's definitely better. And I think I can actually get this to work with only the one screw in. Yeah, that button is gonna drive me nuts. Ah, much better. Now it's not sticking. Okay, there. That's one panel. I'm gonna leave it with the one screw off, just to save myself a bit of time at the moment. Let's try this one next. Oh yeah, did not sand those well enough at all. Or did I? I think it just sits a little higher. No. All of these need to be sanded some more. Where's the rougher sandpaper? I don't have to spend forever trying to sand these. There it is. Oh, I can't wait till I can build a new workbench where I can keep everything far more organized. I actually cleaned and sorted, trying to make sure that I could keep everything organized during the stream, but I'm still looking around for something. even when it's right in front of me. New 3D printer, huh? I would love to get another Prusa printer with the multi-material attachment, and then I want to get both the Elegoo Mars and the Saturn, which is the larger version. And part of my remodel has those options. And then I also I bought those parts bins similar to John's. So I got 6 of those. There's 3 different styles, and I got 2 of each. And they're designed to fit over the new bench. Plus, I have a bunch of LED lighting that will be everywhere. So AliExpress has a sale going on. I bought the LED channel for LEDs that are going to be visible. There'll be some LEDs hidden. Don't think it's really worth putting LED track for LEDs that aren't going to be seen. There's still more stuff to buy, and lumber prices are absolutely atrocious right now, so that doesn't help. I think I priced it out. It was almost $2,000 to build it. I think that will work. Yep. Let's put a screw in it. Screws don't look too bad. Definitely a few changes that will need to happen in the design. So it's a custom L-shaped bench plus a queen-sized loft bed. I have a 3D model of it, but the lumber for it is... Oh, and it has a 3D printing tower. The whole cost of the assembly and material is like $2,000, but that includes 2 tools that I need, because I don't currently own skill saw, as well as the paint. So thankfully I know some people, and I might get some of it at a reduced cost. I'm just waiting to hear back. Maybe I'll get lucky. In the meantime, I just buy a few things here and there as I can afford it. Just bought the upgraded webcam and microphone and headphones. This screw does not want to go in. Why not? Let's try. Ugh. Oh, nope. Dropped a button. Ooh, aluminum extrusion. Oh, that's fancy. Now, where did that button go? all the way at the back underneath the desk. Oh, it's a large printer too. Oh, wow. I think my printer in total, the Prusa that I have, uses like 150 to 200 watts when it's running. It's not bad. Well, that's backwards for one. This button's too tall. And I got another stripped screw. Screws really aren't durable. My goodness. These ones are definitely not fitting properly. I think on this one it's just the 3D print's not tall enough. Yeah, the 3D print on this one isn't tall enough. Needs to be spaced, which I happen to have spacers. Well, in this case, washers, but it should be enough to offset it. I think he said it's 500 by 500, Frank. There we go. Yeah, the 3D print's just a smidge off on the height. A little taller will fix that issue of fitting, but that's another one done. Third time's the charm to hopefully get this to work. Oh no, we gotta sand to these buttons. Let's see here. I'll lose my sandpaper again. Really? Oh, no, there it is. Nope. Let's see. Almost. That feels like it should work. Yep. enough. Yep. Okay, so I actually have to put the second screw on this one, which is fine. It is designed to have both, but tolerance on the captive nut isn't the best. There we go. Make sure the buttons still work. Nope. Okay. Let's throw the screw in here. Okay. The only thing left is to get an Ethernet cable that works. And then we can actually test it. Let's see here. Ethernet connectors and cable. Got my crimp tool. Let's get the Ethernet connectors. Okay, so I do have this cable. No, it's it's not gonna fit. So, pass-through connection. I'm gonna have to trim it. Make it smaller. Yeah, I can make that work. Okay. Cable. Doesn't need to be a long cable. Make sure I got the right order. Yep. Let's try that again. That's one connection, and let's do this last one. connector. Oh, no. I got one of the colors wrong. There. Okay. Now I got a cable. Plug that in there. Plug that into there. Boom. So, who's ready to see this sucker light up? I can only turn one on at a time, unfortunately. And I've set them all up to the same host name anyways. That way I don't have to keep fussing around with Node-RED to turn everything on and off. So, hopefully people are still watching. Okay, let's turn this on. So it's red, so it's connecting to Wi-Fi. White, connecting to MQTT, and green, it's connected. So, I can obviously send LED commands from Node-RED, but I also have it set up so that a button press will trigger Node-RED. So it's white, it's off, white, on, there. And then there are option to fade a color as well. So it fades through the colors through a set of steps, so that it's a proper, it does it mathematically, which I find looks really nice. So you got your static, turns on, turns off, as well as the ability to fade a color. And every 15 seconds it's sending back to Node-RED to be able to... I don't know why it's doing that. It should not be flickering like that. Wondering if that's a power supply issue, because I did not have that issue on my bench. I don't know if you can see it, but it is flickering a little. Now this one is made with the cold white, and so you can see it does work. Now try the other version. The other one, this one should be warm white. Yeah, on my bench it was not flickering like that, so I'm wondering if I missed something for capacitance on that 3.3 volt regulator, or if there's something else going wrong. could just be the 12-volt injection is not a good connection. That one's not even turning on. I'm getting detection on the... Let's see. No, not getting anything on node red. Multimeter. Oh, morning, Dodgy. No worries, Dodgy. There was a lot of fussing to get it to this point anyways. Not picking up 3.3 volts. Let's unpower it. I know that Ethernet was connected because I can see the button presses on the digital pin. So I see the issue. A solder jumper is not connected, and that would cause a problem. I'd almost wonder if you could rotate the D1 Mini so that it was in line with the Ethernet connector. Now, granted, you still have to solder pins in place, but at least I'm not sure if it's cheaper to use the D1 Mini or if the components needed to run the ESP chip on its own is better. To experiment. But if you could rotate it around so that it's so instead of being this way it's this way, then you could still plug in an Ethernet connector and still get at the screws. But if you go surface mount, you wouldn't have to worry about it anyways, and it makes it easier for soldering. But definitely can't keep it like this because you gotta cut a connector to actually fit it properly, which is inviting it to fail. Okay, let's try it again. So, red connecting to Wi-Fi. White and green. White was connecting to MQTT. Now, if I show you my node red So this is a lot of connections for. Oh, sorry, wrong view. Actually, let's go to multi-view. So I have this set up for testing where I can send a bunch of colors, and I can send both static colors as well as control for turning buttons on and off. And which my screen's in the way, but you look at the debug messages, you can see it sends a connected and the host name of the device that's connected. And I have this set up for all of my devices so that when I'm turning something on, I know it has connected. And then with the heartbeat, it sends it every 15 seconds. You could use it to create an offline message so you know if the switch is on or off. And then down at the bottom, I'm simply taking in the heartbeat, sending it to debug, and then taking in the 4 buttons and switching what mode they are doing. So if I push a button, it's blue. Push it again, it's off. This is a warm white switch instead of the cold white from before. And this button is set to fade between warm white and purple. Warm white, yellow. Oh, it's doing the same thing with the flickering as well. I'm going to have to figure out why it's doing that. But got warm white, off, blue, off. So that's that one. So we can turn that off. Let's plug it from back here. And last model is this one. Switch back to full view. I think this one has the same issue. Or not. Oh, this one's not turning on. Let's see. Yeah. Oh, there's a short somewhere. So now comes the question, where is a short circuit? That doesn't register a short circuit. Set in the cable. Cable get pinched. try powering up different board. Oh, that works. Oh, that's got a short. Ah, a little behind, are you? I think I put these NeoPixels upside down. Let's see here. Board view. Ground is down. I did indeed put the NeoPixels in upside down. Let me go grab the hot air station. Okay. Let's see. There's one. That should solve my power issue. Oh, no worries, John. No worries. Let's cool off that board in front of the fan. And let's see if it powers up now. Well, it's definitely powering up. Although I gotta double check these pins. I just blinded myself. Ooh, that's a nice setup you got going there, Frank. Yeah, I actually just got Tiny Pico and 4 MCPs from Adafruit in the mail. I got it the other day, but I haven't had a chance to play around with it. Hoping to put some code together for a light switch controller using the Pico. But I'm gonna use MQTT to connect it instead of serial on Raspberry Pi. Okay, so that should work now. Let's put it back into place. Now where'd the screws go? Well, that's annoying. Just grab 2 new ones then. Yeah, shorting things out from having things floating around. My e-bike has a 74-volt nominal battery, and something that should have been isolated was not completely isolated, and the wrench happened to scrape a coating and find its way to bare metal, and that left me with some nice blisters on my hands and lots of spokes while I tried to remove the wrench, and of course black soot everywhere. And the nurse at the hospital was like, "Oh my goodness!" Yeah, I immediately drove to the hospital, mostly because it hurt a lot. I didn't think I electrocuted myself because I have done that briefly on the 74-volt battery. But the bones definitely sucked. Actually, I remember an incident in elementary school. We had these mobile coats in the school with Mac laptops. And as we all know, Apple loves their very, very thin charging cords. And nobody was really maintaining these coats very well. And it just so happened that finally one of the cables broke and it started sparking up a storm. I was also near the coat. I was cleaning it out and reorganizing a lot of the cables, along with finding out which ones were actually charged, because every other student couldn't get a working one. So I took over the job from the teacher. It was always IT support. But also had magnets in my pocket. Not sure why, but I did. And so that just made the sparks want to come near me. And half the class is then freaking out, and I simply walk over and unplug it, because the switch to turn it on and off was straight through to the back of the thing, right where the cable was that was sparking. And it just so happens, not that I really think it would make a difference, but the third prong, our ground, so to speak, connection for this laptop coat happened to be broken. Not that I really think it would make a difference, because it was the DC side that was failing on the power supply. Why is that one not going in anymore? definitely needs that extra spacer, or washer, so to say. Yep, you definitely do. There's at least where I am for electrocution, they typically run a blood test that will show a certain protein from muscle decay or something like that. And then of course you run your regular EKG if you're check your heart rhythm and stuff, which typically can get screwy if you're electrocuted. The thing I didn't like in my case is that they're like, oh, what are you doing touching it, and yada yada, you're not qualified. And well, I do look young to some people. Some people think I'm older than I actually am, but it wouldn't really matter. You also don't know me, so yeah. But considering I built the thing, or my e-bike, which the battery's on, and I built the battery from scratch, I think I know how to handle it. I thought something was safe. It wasn't. And when I got home, I 3D printed a new cover for it, and now it is safe. If you make a mistake the same way twice, is it really a mistake the second time? There. Okay, now that one's done. The other thing I did with this design, and the reason I like it more than the metal buttons, is these are proud. You don't see a lot of the metal buttons with the tall button on them. They're mostly flush, which is okay if you get the larger ones where it's a little easier to push it. But if you get the itty bitty micro ones, it makes it really hard to push. The other thing I really like about the design, and I showed this at the beginning of the stream, is this. So this one, so these are all printed in ABS, so I can sand them, in this case, up to 2000 grit wet sanding, and then use a plastic polish. And then the lettering is just filled in with nail polish. I find nail polish works really well for this. But what you can do is either use a multi-material extrusion on your 3D printer, or you can load up an STL file with whatever you want written, run it, remove the filament, start your next color of filament, and you can do it that way. But I've found nail polish works quite well for this, and it turns out fairly well. So I did that more as an example. Unfortunately, I noticed on the PCB with the capacitor and whatnot, it won't fit on this, so there's actually a cutout on the model. But I do have to adjust some of the 3D printing tolerances in the model. And now that that's done, let's make sure it actually works. Hopefully I didn't burn out the NeoPixels by having them in backwards. They should be resilient to 3.3 volts. Yes, the lettering is recessed into the print. Red, connecting to Wi-Fi. White, connecting to MQTT. Green, all good. So now, turns on. So this one is, the button itself has a center light. So that one's just blue on and off. This one fades between white and purple. On off for white. Fade on. Fade between white and yellow. It doesn't take much to trigger these buttons. Now this one doesn't seem to have the shimmer issue, so I definitely think it's a power supply issue that's causing the flicker on the other ones, which that power supply shouldn't be an issue, so I think I missed a capacitor somewhere. Typically you have 10 UF and 0.1 UF. So oh, looks like Droid Cam failed. There we go. Now we're back. So the colors are wireless only. You cannot control the color without a wireless connection. The button itself can work both wirelessly and through John's controller. Now, I did make a mistake in the design and didn't put pull-ups in place. So this will not work just wireless. Hopefully it's working again. Droid Cam for the overhead cam had disconnected. I'll wait a moment and see if it comes back. Yes, you can turn up pull-ups in software, and that will work for the D1 Mini, but there are diodes in place, which means it won't work unless you have an LSC connected. In my case, I'm just using this Arduino Mega, so every time I push a button on the Arduino is just letting me know on the digital pin 13 that it is seeing a button press. But obviously there's no Ethernet or anything on it. So if you wanted to use just a terminal block and just send power to it and not have it go to a light switch controller and just rely on MQTT through the ESP, then it won't work. So I do have to add some pull-ups to the design. But the LEDs for themselves, in order to control them, you do need the Wi-Fi. But if the Wi-Fi went down and you are using a light switch controller, it does work without any issues. No, John. There's a diode in place, so without... Ooh, that gets really warm. It was getting so warm. the power supply. I wonder if it's the power supply or the LED getting warm. Yeah, I'll remove this. So if it's the power supply, then that's definitely what's causing the flicker on the LEDs on the other one. Just power it up. See where it's getting warm. Let's see. Red connecting to Wi-Fi, white connected to MQTT, green, it's good to go. Oh yeah. The issue is definitely these power supply chips. Yeah, so these I either have them wired wrong or I did something else. Let's see here. Let's pull up the data sheet. I know some of them use the leg as an output. Some of them don't. And I'm wondering if that's the issue. Let's pull up the part. Yeah, this one doesn't label that tab as an output. So I'd be wondering if it's connected at all or if it's not. Let's try cutting it. Disconnecting it. Oh, I don't think I did connect it. No, I didn't. Oh, it's the revision that I have it connected. Oh well. I still know that that's an issue, so I'm gonna need to find something better. I don't even know which one's the warm white or the cold white. This is the cold white. So, let's see if this one was getting warm too. Red, connecting to Wi-Fi. Green, completely connected. Sometimes MQTT connects so quickly it won't even get the white LED. Yeah, this one's getting hot too. And it's happening very, very quickly. So, that one faded to yellow, faded to white. So, not sure if there's anything more to show for these. Anyone have any questions? I can answer them now or answer them in Discord later. But that power supply needs to be changed because that flicker is from that power supply. And even with 4 LEDs, it seems like it can't handle it. Not entirely sure why, but it can't. Volume? I'm pretty maxed out on volume. I don't know why it would be quiet. Yeah, I'm maxed out on volume. Unless I'm just not talking loud enough. Really? Am I not talking loud enough then? Or maybe I'm not talking close enough to the microphone? Well, it somewhat works. Definitely some changes need to happen for Ethernet cable, the mounting of the D1 Mini, power supply so that it stops flickering the lights. And making sure that if you're not using a light switch controller and you're just powering it, that it can still work, which right now the buttons won't work without the light switch controller, and that is getting hot. Yeah. So any other questions? Things that I can show? The code is already on GitHub. I used tabs in the Arduino IDE, so there are multiple files with all the voids. Thanks, John. Yeah, I figured the possible customizations over the metal buttons kind of gives you some other options. And while the metal buttons are expensive, I've found out to produce this is a little bit pricey too. Parts aren't bad, they're about $30. The shipping on the circuit boards is not great. But the idea would be that people could 3D print their own pieces. But I could offer it as a complete kit. But it would depend on what people would want. Yeah, I haven't programmed an animation yet, but you could animate the buttons if you wanted. To kind of do like a ring light almost. But right now it's static. I find the ESPs are not the nicest to work with when it comes to the NeoPixels. It tends to have issues with the watchdog resetting everything, which when I was first programming this yesterday, I did run into that issue, but I solved it. So right now the code online does work for these, and they're quite easy to interface with. If I go on here, yes, the symmetry does open up quite a few options. Go to here. Nope, wrong view. This view. There we go. So I'm going to Node Red. We go here. It's not powered, so it's not sending anything. But the way you can interface with it, you have the name of the switch, which in the code you can set the host name. And that host name ends up being the first name in the topic. So these one, so this one is rough sanded 180 grit. There's still a few imperfections. I didn't spend a lot of time soldering these. You could set a node ID. I guess you could put jumpers for that. The only issue, you'd probably need a lot of jumpers, especially if you start putting in a lot of switches in. So I mostly just left it up for people to decide what they want. And then the other thing is when you set that node ID or host, as I have it labeled in the program, it actually sets what your Wi-Fi will see it as. Yeah, you could do it dynamically. The reason I chose not to do it dynamically is simply because I like knowing what a device is on my network, rather than everything showing up as ESP something something. I already have a few that do that, and I just haven't taken the time to change their code. That way, if it's not working, I can easily go identify which one it was, rather than playing the guessing game. I also haven't added heartbeat code to all of my devices. This code does, every 15 seconds, it sends a 1. So you could use a delay or a timer in Node-RED and have it know if you're not connected. So this is, it automatically puts the host name in, and then the slash heartbeat is for the heartbeat. Regular button presses coming through the slash button, and then it's sorting each button. The trigger is just the number for the actual button. So if it sends a 0, it's because button 0 was pressed. I do have a slight issue with sometimes it double presses, even with a debounce, so I have to figure out why it's doing that. It's mostly if you're holding it for a moment and then releasing it. If you're holding it for a while, it tends to trigger. It also can't do multiple buttons at once, so that should be fixed. But for the most part, it does work. And then simply the switch command is changing from the change state machine, and then you're sending out the topic, which RGB just changes the color. Yeah, that's probably the issue, is the debounce on release. So topic RGBW just changes the color. It doesn't do anything fancy. And then your payload is the LED number you want to change, and then the RGB value, RGB white value. And then the other option is to fade between a color, which I find works really nicely. So you can do slash fade. And I was running both effects on the buttons. But that's the code right now. Thanks, James. Yeah, I figured it was easier to use a topic to control it. As John was saying earlier, you could, the especially with the 4 LED ones, you could make a lot more customizations in terms of animations. But I kind of threw the code together yesterday. I had been playing with animations just to see what the lights would look like. But yeah, definitely have to play around with power supply IC chips to figure out why these get so hot. Now these buttons are connected through diodes, so there shouldn't be that much noise on release. I mostly did the diodes to separate it from the Ethernet connection, but I will add extra diodes on the Ethernet side as well as keeping the ones on the ESP side, and then I'll be able to add in pull-ups. Yeah, when I ran running the strand test from Adafruit on it, you can do the animation. Now there is issues with running strand test on its own because it does cause the watchdog to reset every time it finishes. But playing with the code, you could add more animations to it. Yeah, definitely think the next step is I'll have to change 3D models so that I'm not doing a whack of sanding each time, and then make new circuit boards. I love how satisfying these things click. These click so nicely. I didn't actually expect this to work as nice as it does. Now the other one, this one with the center buttons, they look nice, but I really like the ring light better. Having the ring light up looks so much nicer. But yeah, I don't think there's much else to talk about unless anyone has any questions. Everything else, probably post a photo or two on Discord and go from there. Do you want a close-up pic on the stream or just in Discord? Because I can definitely do a close-up on Discord. Discord? Yeah, okay. I'll post on Discord. Thanks for watching, guys. Hopefully I can keep doing more streams and showing off stuff that I'm working on. But yes, I will